So let's say if we have an open circle at this point, a closed circle, and also another open circle. What is the limit as x approaches 2 from the left side? So this is known as a one-sided limit. And let's call this function f of x. So basically, this question is asking you, as x approaches 2 from the left, what is the y value? So here is an x value of 2. As we approach it from the left side, notice that the y value of that curve is 3. This is 1, 2, 3. Now, what is the limit as x approaches 2 from the right side of f of x? Now, if we follow the curve from the right side as we approach an x value of 2, notice that the y value is -4. Now, how about the limit as x approaches 2 from either side? Because the left side and the right side do not match, this limit does not exist. Now, what about the value of f of 2? When x is exactly 2, what is the y value? So we have to look at the closed circle. The y value is 1, so f of 2 is equal to 1. Now let's try another example. Let's say if we have an open circle at that point, and a closed circle here. What is the limit as x approaches +3 from the left side? And this is the graph of f of x. So here is an x value of 3. As we approach it from the left side, notice that the y value is 2. So this is equal to 2. Now, what is the limit as x approaches 3 from the right side? So as we approach an x value of 3 from the right side, the y value is still 2. Now, what is the limit as x approaches 3 from either side? Because these two values are the same, the limit exists. It's equal to 2. Finally, what is the value of f of 3? When x is exactly 3, what is the value of y? So whenever you get a question like that, look for the closed circle. The closed circle has a y value of 4. So f of 3 is equal to 4. Consider this one. So what is the limit as x approaches 2 from the left side? And what is the limit as x approaches 2 from the right side? And then find the limit as x approaches 2 from either side. And in addition to that, find the value of f of 2. So go ahead and pause the video. Go ahead and find the answers to these problems. So let's start with the first one. So here's an x value of 2. As we approach that point from the left side, notice that the y value is also 2. Now, as we approach x equals 2 from the right side, the y value is still 2. So therefore, the limit as x approaches 2 from either side must be 2 as well, because the left side and the right side have the same y value. Now, what is the value of f of 2? So when x is exactly 2, what is the y value? Notice that there's no closed circle in this particular example. So therefore, it does not exist. If you don't see a closed circle at x equals 2, f of 2 is not defined. Now let's look at a fourth example. What is the limit as x approaches 4 from the left side? And also find the limit as x approaches 4 from the right side. And as x approaches 4 from either side. And also find the value of f of 4. So what is the limit as x approaches 4 from the left? Looking at the graph, here's an x value of 4. So as we approach from the left side, notice that the y value is approximately -2. Now, as we approach +4 from the right side, the y value is still -2. So the limit exists. Since the left side is the same as the right side, the limit as x approaches 4 from either side is also -2. Now, what about f of 4? Notice that we do have a closed circle at x equals 4. So it's also equal to -2. So therefore, everything is the same. The function is continuous at an x value of 4. Here's another problem that you can try. So what is the limit as x approaches 3 from the left side? Let's start with that. So what do you think it's equal to? So here's 3. It's the vertical asymptote. And as we follow the curve, as we approach 3 from the left side, notice that it doesn't converge to a specific y value. It keeps getting lower and lower and lower. So therefore, it goes to -infinity. Now, what about the limit as x approaches 3 from the right side? If we follow the curve towards the vertical asymptote with an x value of 3, notice that it keeps going higher and higher and higher. So therefore, it approaches +infinity. Now, what is the limit as x approaches 3 from either side? Because these two do not match, the limit does not exist. Now, what about f of 3? We don't have any closed circle at x equals 3, so therefore, f of 3 is not defined. It doesn't exist. Let's try another similar example. What is the limit as x approaches +4 from the left side, given the graph of f of x? So here's the x value of 4. And as we approach it, notice that the curve increases. It keeps getting higher and higher. So the y value approaches infinity. That is +infinity. Now, as we analyze the limit as x approaches 4 from the right side, as we follow the curve towards +4 from the right, it also keeps going higher and higher. It goes towards +infinity. So therefore, what is the limit as x approaches 4 from either side? Since these two are the same, you can see that it approaches +infinity. Now, granted, infinity is not really a number. I mean, infinity could be a million, a billion, a trillion, or just something that's it's a never ending, it's just keep increasing. So because it doesn't converge to a specific value, you could also say that this limit does not exist. Some textbooks will have this answer, some will have infinity. So infinity really doesn't exist. It's just a way of describing what happens as x approaches 4. That is, the curve gets bigger and bigger and bigger. The y value, that is, it gets higher and higher and higher. And we know that f of 4 is undefined. It doesn't exist. We don't have a closed circle at x equals 4. Now, let's work on some examples with horizontal asymptotes. So let's say if we have a horizontal asymptote at y equals 3 and another one at y equals -4. And let's say the first graph, well, let's say we have a curve that looks like this, actually. What is the limit as x approaches +infinity? What is the answer? So this is saying when x gets very large, that means as we follow the curve all the way to the right, what is the y value? Notice that it approaches the horizontal asymptote, so it has a y value of 3. Now what about the limit as x approaches -infinity? So if we follow the curve all the way to the right, notice that the y value that it approaches is -4. So that's how you can evaluate limits at infinity when x becomes very large. You need to find the y value of the horizontal asymptote. When y becomes very large, when y approaches infinity, you need to look for the vertical asymptote.